Okay. Apologies, everyone. Technical difficulties continue. Okay. So not this. The next one. The next slide deck. Yeah. No. The next one. Yes, that's the one. Thank you. Okay. So I think this is a call for just moving on slightly quicker than what we even planned. Malte, can you mute, please? We can hear you. Malte, we can hear you. Can you mute, please? Okay, so what I'm going to go through fairly quickly, much quicker than what I anticipated, is the Malte, can you hear us? Can you mute him? Okay, so I'm just going to go fairly quickly through the process for the creating the AR6 scenarios database. So as you know, a key part of the assessment was a body of scenarios that we assessed for the long-term mitigation scenarios. And here I should give credits to my colleague Ed Byers, who managed the entire process throughout AR6 assessment cycle. So we put a call for climate scenarios. Now the clicker is not working. It's not working. And we received 2,266 scenarios, and these scenarios were undergone through an initial vetting criteria to make sure that the baseline period of these scenarios are within reasonable range for certain emissions and key energy indicators. So, for instance, in line with estimated primary energy by IEA. And then, oh yeah, I can use it now, I think. Not okay, yeah. And then 1,686 scenarios passed this vetting stage. And then next we moved on to the climate assessment of these scenarios. And for this, what we did is essentially in AR5, the climate assessment was based on concentration in line with Article 2 of the UNFCCC, while in SR 1.5 and AR6, the categorization and the climate assessment of these scenarios was based on the level of warming in line with the Paris Agreement. So for this climate assessment, we used a AR6 working group 1 climate models, AR6 calibrated climate models that were calibrated by our colleagues in working group 1. And I'm not going to go through the climate assessment pipeline. That's what I was planned to do earlier. But I'm just going to jump in and we say that what we did is essentially we categorized these scenarios in 8 categories, starting with 1.5 degrees with no or limited overshoot, C2 also 1.5 high overshoot, and then C3 2 degrees, limiting warming to 2 degrees, and C1 to C3 are in line with what we assessed in the SR 1.5. And then the remainder of the categories, C4 to C8, are essentially a disaggregation of the entire scenarios body in order to ensure, to capture higher level of warming. Okay, so, right, okay. Next, yes. So as I said earlier, we had 1,686 scenarios that were undergone the climate assessment. And here what we show is the number of scenarios in each climate category. And as you can see, the number of scenarios that undergone the climate assessment or passed the climate assessment was reduced to 1,202 scenarios. What we see here in the bar chart is the distribution of the scenarios in each climate category from C1, C2, C3. Again, they are in line with SR 1.5. And then the rest of the categories which are for higher level of warming. And you can see a big gray bar at the end, which essentially illustrates the number of scenarios that did not pass the climate assessment. And the reason for that is that these scenarios did not have enough information about gases that have high level of radiative forcing. So we were not able to do the climate assessment with high confidence. And for these exactly. So K1 next will take us through a detailed assessment of these 1,202 scenarios. And then before K1, what we will have Malte, who will take us in more details about the climate assessment itself from working group 1. And then we took a subset of this large body of scenarios in order to illustrate certain alternative mitigation strategies. The storyline of these mitigation strategies were emerging throughout the assessment across the entire report. So here essentially we are trying to link the bottom-up assessment with the top-down assessment and trying to emphasize a key aspect of these alternative mitigation strategies. So we have 7 illustrative pathways, 5 of which are mitigation-based, hence called illustrative mitigation pathways, and then 2 of those are representative of current policies or a modest action beyond what we have at the moment in currently implemented policies. And for that, we have Detlef who will talk about this in detail. So we will move next to, yes, so this is just essentially showing the number of scenarios by each modeling family. I think it's important to stress here that this is an ensemble of opportunities. It's not a statistical sample of hypothetical scenario space or model space, because we don't know if the current literature covered the entire scenario space and model space, and B, not all scenarios in the literature were submitted to the database or were able to submit to the database. So that's why we call it an ensemble of opportunities. I'll leave my key messages for later, and I'll move to Malte. Malte, I think you can now start sharing. So if
Hello, can you hear me?
yeah, Malte,
we can
you
hear
share
you.
your slides, please? Yeah, we can hear you. Can you hear us?
Okay, I'll start sharing. I continue under the assumption that you can hear me.
Yes, we can hear you. Can you hear us?
So thank you very much. I wanted to start that this is my lowest carbon COP ever travel. What a great experience. There's some small things to be ironed out. Anyway, I try to keep it short. I hope you can hear me okay. So it is now on the working group climate assessment. I briefly talk about how working group climate the climate projections, and then how it is represented by the climate emulators, how that is used to then assess the thousands of scenarios in the written routine database to gain insight on one quite likely degree and other things, and also the brief currently the warming between 1815 to 2020 is shown here now in the blue curve. So this is assessed warming from just the two vertical one. You can see here in the little gray lines the synopsis models, and just for within recent period maximum 0.8 5 people that's assessed warming by just the two, and this is something that's 16.7. So how do these indicators then calibrated as indicators will in the past they went very well. Here's for example the typical model in pink, and the fair model here in turquoise, the magic model, and then the external UFO indicators in green, short temperatures in blue. The climate emulators a good job on historical warming, but what about the future? And so then we have the cost of the box as in one, and then if you look at, for example, the 1-2-6 scenario that was done by this 6 models, we can look at here the near term, the medium term, and the long term. And looking at 1 for the first time ever did not only use the CMAP6 or system models, but made an assessed range based on multiple lines of evidence. For example, paleoclimatic evidence to also look at equilibrium climate sensitivity and transient climate response, and the experts are also sitting with me there in the room. I just saw them before. So you see here the mid-term, medium-term, and long-term, you have the assessed ranges that are a bit lower than at least the upper end of the CMAP6 models. Now, we calibrated the emulators to represent that range, not only for the SSP 1-6 scenario, but also for other scenarios. Let's have a look at how it works. And here, the 6 model, again, for the midterm, medium-term, doing a fantastic job. In the long term, they test the report. Here's a fair model, here's a magic model. And one thing you see is that the range of the uncertainty by working with 1 is very well represented by the emulators. The Oscar model, the range was not fully calibrated, so we can use it then for the working with 3. One thing that is important, the difference between working with 1 and working with 3 is working with 1 scenarios are classically run from concentrations. And so we describe concentrations and then we look at temperatures, but working with 3 scenarios are starting from emissions. So the fair model and the magic model here include these carbon cycle uncertainties that you see in these small bars here, so the uncertainty bar gets slightly wider, and we then took the fair model and the magic model further to assess the working with 3 database. We have a lot more indices there in the cost chapter of chapter 1, table 2 in working with 1. Now let's have a look in the working with 3 classification. What you see here is the median across the C1 scenarios. And there the median is just around 1.5 degrees, so around 2040s, 2050s, and then goes below 1.5 degrees by the end of the century. That is just here the range of the 97 scenarios that are part of the C1 class, but that is just the median. So we here see that also on the right side, the 2100 warming is below 1.5 degrees. We can go to the next higher class, the C2 class, that has a higher overshoot, roughly to 1.7 degrees, and also by 2100 is below 1.5 degrees by design. This is the scenario classification. We here on the overshoot, there are of course then to come down to below 1.5 degrees. There are negative emissions necessary, and there's a separate IPCC event, hopefully with less technical issues. Tonight, I would highly recommend that one. We should not forget that these bars here, they are only the medians, and as we saw in the previous slide, there is still quite a bit of climate activity. That means if we aim now for the best estimate 1.5 degree warming, we might still want to be prepared for warming above 2 degrees. The graph in 3 here is very rich. The peak warming is also here indicated by these 4 little bars. And then the next higher class is C3. C3 doesn't go below 1.5 degrees, but it stays lightly below 2 degrees for the entire time. And then we have C4 that only 50% chance are higher to stay below 2 degrees. C5 below 2.5 degrees, and C6 below 3 degrees. And it's in that range between 2 and 3 degrees that you see lots of studies like the UNEP report, the UNFCCC synthesis report, and other analysis that look at the implemented policies and the projected warming resulting thereof, that they end up between 2 and 3 degrees. Or if you take, for example, the NDCs until 2030 and then make some kind of assumptions of similar effort, we see warming between 2 and 3 degrees. If you were to take into account the net zero pledges and assume that they are fully implemented, then you'll end up slightly below that. There's also higher classes C7 and C8, but with the falling renewable prices, we would have to take money in our hands in order to achieve these emission levels. However, the warming levels they represent are not fully redundant because we might still reach them if the climate system is a bit more angry than what we expect at the moment. And these are the C scenario classes from working group 3, and the illustrated scenarios from working group 1 are shown as very small dots. The SSP119 scenario that is in the C1 family, the SSP126 scenario in the C3, and SSP245 up here. And then my colleague Detlef from Ruhren is then later going to talk about the harmonics and key scenarios that are also impacted here. Now, this is the full beauty of that figure that we find in working group 3 as being one box to the one. Now, we just putting these scenarios in the context. If we look at here, historical emissions and trends from currently implemented policies is rather flat line, simplified speaking, but if the scenarios projected out to 2100 can be a rather widespread. Here the blue bar is scenarios that aim for the NDC levels by 2030, and as you all know, the gap towards 1.5 degree scenarios by 2030 is rather wide, and with the 2-degree scenarios it is roughly half in 2030. But if we want to start here our climate action journey from 2030 without improving the NDCs up to 2030, then we only have the choice of making steep reductions and getting back into the 2-degree territory. The 1-degree, 1.5 degree boat has probably left the harbor by then. So here we have steep reductions and then even no negative emissions later on. Then we still have about below likely below 2 degrees warming possibilities. But that is at the cost of humanity. And that is the very similar analysis from many of the recent reports, IPCC, synthesis report, NEPCAT report. They are all very similar. Steep reductions before 2030 are necessary to avoid either steeper reductions after 2030 and still in a higher overshoot of 1.5 degrees or 2 degrees. Or then if we don't do any steep reductions at all, then we have warming in excess of 2 degrees. And I just, in the interest of time, I keep it at that. So here, the scenario classifications in 1.5 and AR6, then they turn out to be remarkably similar. If you look under the hood, there are 2 main offsetting effects. In AR6, we have more aerial cooling that brings all the temperature assessments slightly down, but we also have a higher historical warming estimate that brings them all up. And when we compare them, here in AR6, we have slightly higher peak warmings and slightly lower long-term warmings than we can in the IPCC as a 1.5 setup for this 9 classification in AR6. And with that, I pass back to Jean Shai, and I can't see you, so questions are going to be answered by Kayvan, Allah, or Alison.
Okay, thanks very much, Malte. All right. Can we, you can't hear me, can you? Okay, we'll move next to K1 to talk to us about the assessment of the scenarios body in working group 3. And just to say, I'm sorry about the difficulties. We will upload these slides online after the event. Okay, so over to you.
Yeah, thank you. Thank you, Allah. I hope you can hear me. It's really a pleasure to be here. I want to, I don't have the clicker, so okay, thank you. So I want to take it on there where Malte left us with the categorization. And that doesn't work. Yes, next slide, please. Yeah, and the categorization of scenarios have been synthesized, and some of the most important benchmarks have been presented in the summary for policymakers of the Working Group 3 report in this relatively complex table. It basically shows you the different categories, but then it shows you also for the different warming categories what's the timing in terms of near-term mitigation reductions that are needed in order to stay within the individual temperature categories. You can also see emissions milestones in terms of when do we need to reach net zero CO2, when do we need to reach net zero GHG, consistent with the different warming categories. And you can also see the cumulative emissions, or in Working Group 2, Working Group 1 language, the budget within cumulative CO2 emissions need to lie in order not to, in order to be consistent with the categories. And then finally, the last two rows give you the peak temperature as well as the likelihood of the peak temperature of the different categories. Next slide, please. Yeah, let me focus perhaps on the category 1. These are the lowest scenarios that we find in the literature, which limit warming to 1.5 degrees with no or limited overshoot. These category has actually split into two different subcategories. Those scenarios that we reach net zero GHGs and those scenarios that do not reach net zero GHGs but still are able to keep warming below 1.5 degrees with low overshoot. You see the two different categories in terms of the emissions dynamics on the right-hand side. The light blue ones here are the ones which don't reach a net zero GHG, and the ones that basically reach net zero GHG and go even slightly negative are shown in turquoise, or a little bit darker blue. Let us, next slide please. And then let us click perhaps next, next, and next. Great. So there are a number of common characteristics of scenarios that meet net zero GHGs and that do not meet net zero GHGs and are consistent with 1.5 degrees and low overshoot. One is they all have roughly a peak warming of 1.6 degrees. So as Malte just showed us, there is a slight overshoot in those scenarios, in both of them. They all are roughly consistent with the global carbon, with the cumulative emissions to net zero of about 500 gigatons of CO2 between 2020 and the time of net zero. And the third important point is that both scenarios are also consistent with a very similar timing by when CO2 emissions become zero. So CO2 emissions become zero in these scenarios around 2050 to 2055. And this is the case. Yeah, this is a very contentious point, the net zero CO2, but net zero CO2 is between 2050 and 2055 in both of these categories. Next slide, please. There are important differences between C1A and C1B category. Yes, click. First of all, in those pathways that achieve net zero GHGs, this is happening 20 years, 10 to 30 years after the pathways achieve net zero CO2. So there is a lag between that. Next slide, please. In order to achieve net zero GHGs, one needs to achieve negative CO2 emissions. Negative CO2 emissions in order to offset remaining positive greenhouse gases from other non-CO2 gases. And this is also why those scenarios that achieve net zero GHGs rely more on carbon dioxide removal from the atmosphere and also higher cumulative negative emissions. And this is in these scenarios in the order of minus 360 gigatons with an uncertainty range of minus 140 to 680. So quite substantial negative emissions in the second half of the century in order to basically achieve net zero GHGs and go below this. Next, please. And as a consequence, the advantage of scenarios that achieve net zero GHGs is that the long-term temperature is significantly reduced from the peak warming of 1.6 degrees. So in the C1A scenarios, we have a long-term temperature of 1.2 degrees. in the C1b scenarios, which do not go negative, we have a long-term warming of 1.4 degrees. This difference is particularly important for impacts which are impacted by transitional temperatures being relatively higher, for example, sea level rise. Next slide, please. Yeah, some comments on net zero CO2. I've been told I should accelerate and perhaps not use my full 15 minutes, but let me make three quick points. The net zero CO2 timing is, of course, a good indicator of the peak warming of the scenarios. This is particularly the case if the shape of the pathways is the same, because it's not necessarily timing of net zero, but it's the cumulative emissions until the timing of net zero, which determines the peak warming of the scenarios. Next, please. This means at the same time that scenarios that have the same net zero CO2 timing and reduce emissions relatively slowly at the beginning and have more cumulative emissions by the time of net zero have generally a higher peak warming. So in order for the same time of net zero to reduce the peak warming, early near-term CO2 emissions reductions are possible, right? So that's also the reason why you see an uncertainty range of net zero CO2 timings for each individual category in the table that I've shown before. Next, please. Finally, you could, of course, put this around and ask the question, for a specific given peak warming, when do net zero CO2 emissions need to become zero? And the answer to that is that net zero CO2 emissions need to become zero the earlier, the less you do near-term mitigation. So scenarios that wait in the near term need to crash emissions more strongly later on and need to achieve earlier net zero CO2. So the lack of action that we see at the moment following the NDCs means for the same peak warming, we need actually to achieve net zero CO2 earlier and earlier. And the mitigation challenge is increasing further and further. Next, please. Yeah, let me perhaps make some quick points about the underlying equity assumptions in the C1 pathways. First, about the economic equity. In all the C1 pathways, what you can see is that economic growth is continuing both in Annex 1 and non-Annex 1 regions, but this economic growth is more rapid in non-Annex 1 countries compared to Annex 1 countries. And this is what you see in the lower panel. The lower panel shows that generally economic equity over time increases in the C1 scenarios and hence is also consistent with the historical trends. To give you an example, income differences between Annex 1 and non-Annex 1 countries are today around 1 to 4. They are on average closed in the scenarios to 1 to 3 by 2050. And there is particularly some scenarios that are very equitable, and these are those that have been selected because of that characteristic, like, for example, the IMP-SP, so the illustrative mitigation pathway, the shifting development pathway shows the highest equity among all the different pathways, and here the income gap between north and south is reduced over the next 30 years by a factor of 2, and the income differential is only 1 to 2. By 2050. Next, please. Energy is a relatively similar story. Rich countries reduce their energy consumption while the developing world manages, because of increased efficiency and energy intensity improvements, to keep energy demand relatively stable. As a result of that, also the energy equity improves across the scenarios a lot in case of the C1 pathways and in case of keeping warming below 1.5 degrees. Next, please. And finally, the same improved equity you see also, of course, on the level of emissions. Emissions come down more strongly in Annex 1 countries and more rapidly, and the per capita emissions converge over time, which means that by 2050, there are very similar per capita emissions levels in the rich and in the poorer countries across the world. So basically, equity is improving in these very stringent scenarios on an economic basis, on an energy basis, as well as on an emissions basis. Next slide, please. A very important caveat in the pathways of the AR6 assessment is that all the mitigation pathways have been developed with the framing to try to achieve those targets in a cost-effective way. This is consistent with Article 3 of the Paris Agreement, but it does not consider the issue who is financing those investments. So you have a cost-effective investment in different regions, and it's not clear who needs to finance that. New analysis based on the AR6 pathways, which are not in the sixth assessment report, and this is the slide about this, show that for an equitable and fair finance of those regional investments, a major increase of those finance flows are necessary. So we know how to achieve the cost-effectively the targets, and there is a new paper in Science actually coming out in the next 2 days, quite timely for this COP, shows you under different ethical principles of interpreting fair and just transitions, how much that finance actually needs to increase. And this is something that you see on the right-hand side here. Please do not tweet this figure because it's going to be out in 2 days. Then please tweet it a lot. But at the moment, don't tweet it. Thank you.
Thanks so much, K1. Just to note, as K1 said, the final few slides are new work that has been added after the assessment. We'll take the questions after, I'm afraid, not now. Okay, so we'll move to Detlef, and I hope, Detlef, you can hear me, and would really appreciate if you can do it in 7 minutes instead of 10, and that would leave us with 10 minutes Q&A in the end. Over to Detlef.
Okay, so we move to Detlef, and I hope that you can hear me, and really appreciate if you can do it in 7.
I'm traveling through time.
I hope I'm unmuted and you can see me. Can you hear me? If you can hear me, can you show that you can hear me?
Yeah, can you hear us?
Hello, can you hear me?
We can hear you. I don't think you can hear us, but hopefully my thumbs up.
So I hope I'm share my slides as well.
Yes.
Okay, so I'm going to talk about emission reduction pathways as illustrated by the mitigation pathways in the Working Group 3 report. And so in the next slide, you see the scenarios that we have qualified as current policy scenarios, which includes those that have current policies and the NDCs, and they compared with the C3 and C1 pathways as already introduced by K1 and by Malta. And so the question is, how do we reduce the emissions from the current policy scenarios up to the C1 and C3 scenarios? And obviously this is done in the model by a combination of efficiency improvements, substitution and lifestyle change, substitution to low and zero emission technologies, reduction of the non-CO2 emissions, and negative emissions from types. I've indicated also some examples of each of these categories. So basically, we need deep reduction. So all these elements are in any of these scenarios, and we see transitions in buildings, industry, transport, energy, agriculture, land use, and consumption. This can also be illustrated by a graph that is in the SPM of the 3 report, where we show how we move from the current emission level into the level that is net zero, as in the scenarios between C1 and C3. We show that there are emission reductions in buildings, industry, and transport, indicated in dark blue, light blue, and purple. But we also distinguish there between direct emission reductions in the sector itself and indirect emission reductions by reducing the emissions from the electricity that is also added up in the red bar, where we also show emission reductions in total fossil fuel energy consumption, either directly in sectors or indirectly by decarbonizing the electricity that is used in these sectors. Then we also show that there's an additional contribution from land use change in green and from reducing the non-CO2 emissions in gray. For 2030, the IPCC report also supplies in-depth analysis from the reductions options, and this, I've added those up, and you can see that by 2030, if you look at all the options that are available, then those easily make it possible to reduce emissions by more than 42%, as you see it for the C1 emission reductions. You don't see these sectors contribute the most, and so the most renewable energy and EV and some power, but also reducing emissions from land use change and by reducing deforestation and increasing afforestation, important option, efficiency improvements, and reducing the non-CO2 options, and also our supply changes, including, for instance, moving away from coal to low carbon emission options. We can also look at the different scenarios and look how different options play a role. This is done here by plotting from right to left the CO2 emissions, so meaning that we go from the high C classes, C7 and C8, to C1 and C2 and C3 on the left. And you can see that if we move to more stringent scenarios, for instance, renewables goes up, decarbonization is more rapid, there's more CCS use for emissions. But you can also see that there's a spread. So scenarios that are consistent with C1 or C3 generally have high use of renewables, more than 40%, but there is a spread. And some scenarios are higher on renewables, but some are somewhat lower, and that's then compensated by negative emissions. So we want to illustrate that and to select scenarios from the database that illustrate the main points. And so we selected illustrative strategies, so current policies and NDCs, and that we also selected mitigation pathways. And one is about credible strengthening, which means that the scenarios first meet the NDCs and then try to come back. Those scenarios can only go to C3. Then we have scenarios that focus mostly on net negative emissions. We want to illustrate the strategy of focus on resource efficiency, focus on sustainable development, and focus on renewables. And so this is shown here. And so from the database, we selected, in the case of mitigation scenarios, 5 scenarios that nicely illustrate these different strategies. And so, for instance, there is this INP negative emissions, where you can see that negative emissions compensate some of the remaining emissions that are still in that scenario when it reaches net zero. The graph here shows the emissions in different sectors when they reach net zero. The negative emissions in this case are by afforestation in green and by the negative emissions from energy in orange. But it can also be different, and so that's why the IPs are so useful. And we can also show a scenario that mostly reduces demand, and therefore it doesn't need as much negative emissions. Here in this case, the only negative emissions are increased afforestation, and because there is much less remaining positive emissions due to lower demand. As Kewan already indicated, we have also an INP shifting pathways towards sustainable development, and that scenario shows how climate policy can be combined with the SDGs and equity policies. We have the renewable INP, which illustrates mostly the impact of using renewables, and the gradual strengthening scenario, which shows that there is a pathway via the NDCs, but it will require so much strengthening that can only reach C3 at best, and has this very rapid reduction period that we make uncomfortable crossing. And so this is how we can use the INPs. We show that successful mitigation strategies consist of a combination of non-mitigation, substitution to low and zero technologies, induced deforestation, and reduction of non-CO2 emissions. We also show that there's enough reduction potential in 2030 to meet the C1 to C3 categories in the INDs and national constraints. This is what I wanted to show today.
Thank you very much, Detlef. I'm not sure if you can hear us. I don't think you can. Okay, we'll take questions from the floor, and we'll do our best to cover all the grounds. So, Raj is going to help us with the question. Please, questions from there. So, yeah.
Stefano Battistone, University of Zurich, and Chapter 15. Two questions. Hi, Detlef. One is, could you give us a sense of the implications of those 360 gigaton of negative emissions in terms of scaling up of technologies that are needed? And then the second question is kind of the obvious and tough question: how much of the scenarios that we've been working on will stay in the face of the recent geopolitical events? What would be the shift in warming or in years with respect to the achievement of the net zero because of the current developments? I know it's a difficult question, but just,
Thank you. I think the two questions are great. We'll take one more person, and then we'll go a quick round. So, any questions from the floor? Roger, if you please stand. Thank you.
Hi, Robert Gibson, Civic Exchange, Hong Kong.
Thank you.
Has there any, the scenarios which require a significant amount of carbon dioxide removal, has there been any estimate as to what percentage of GDP, global GDP, needs to be spent to create those carbon dioxide removal credits?
Thanks so much for the question. Okay, I think we'll stick with these three questions. And then, so we have the first question, 60 gigaton of negative emissions. What is the level of scaling up the technology? Maybe Keyvan, you would like to answer?
Yeah, so this is of course strongly scenario dependent, and it depends also strongly on which of the sectors at the end will contribute to that negative emissions tail, if you wish. For example, in the low demand scenario, the IMPLD, which is the illustrative mitigation pathway with the low energy demand, this doesn't rely at all on technological solutions and shows how this order of negative emissions could be achieved through enhancing the biospheric thing, particularly to afforestation. But there are also scenarios that include much more technical options, like combining bioenergy with CCS. And there, the upscaling indicates that over the next years, over this formative phase, you would need to have in the orders of hundreds of megatons upscaling of those technologies over the next 20 to 30 years. So over the next 18 years, so by 2040. But this really depends on the policy choices and the emphasis on how to achieve that goal. The slower you scale up technology-based CDR, the more you need to rely on the biospheric thing.
Thanks so much, Keyvan. Detlef, would you like to add to that? I'm not sure if Detlef is hearing us. Okay, given the technological difficulties and limited time, we'll move to the next question. So how much scenarios will stay within range or within reason, given this recent geopolitical development? Keyvan, I'm afraid I'm going to have to rely on you on this one as well. And maybe if you can pick the next one, which is the GDP implications due to level of CDR. You can hear us? Okay.
We have to use
Okay.
So, we know that there are consequences, for instance, in terms of energy for some of these options. time they have consequences. And so therefore, our IOPs like IOP or not might also be affected at the same time.
Thanks so much, Detlef. Kevan, would you like to cover the other question?
Yeah, so one question was about what the energy crisis might mean for the pathways. So basically the pathways do not include several elements of the crisis which are relevant for the climate targets. One is the geopolitical fragmentation. So the pathways all imply that there will be collaboration across the world, and it will be absolutely essential to achieve those targets. I think there are other important dimensions here. There is a dimension of acceleration of switching away from very high-priced fossil fuels to renewables. So in some parts of the world, you can see that the crisis has actually led to an acceleration of expansion of renewables, acceleration of changing heating systems in houses, electrification of mobility has accelerated because of the high prices of fossil fuels. On the other hand, you see also that in the minds of people, sometimes the current high energy prices and the crisis is seen as if there is a need to stay in fossil fuels, because without fossil fuels the prices would be so high. But we are dealing with a disruption, and how this will translate at the end into scenarios. This is at the moment very difficult to I think to project. Many different teams are working on looking at this crisis as a branching point. Are the accelerators bigger, or are those barriers bigger? In my personal view, I think the biggest barrier at the moment is the lack of collaboration and the fragmentation that we see in the world. I think geopolitically, this is a very tough situation for international climate policy. There was a question of percent of GDP. Yeah, so in percent of GDP, this will be a very tiny number. I have not calculated it. For the next 8, let's say for the 2030 target, the amount of CDR contributing to the real reductions will be relatively small. So when we get to net zero, we are talking of about 3 to 4 gigatons of CO2. You can calculate it actually. You can take any number between $30 to $100 per ton of CO2 for the CDR, perhaps $200, and then you could calculate some sort of fraction. But this needs to be done more carefully. So I think we need to look into the investments in the scenarios, calculate it, etc. But as a proxy, you could do a calculation like this. You could take a carbon price will actually be too high. No, I take that back. You could, I take that back, because the carbon price is the marginal price, and multiplying it through to the amount of CDR will give you a much higher number than the real investments in the CDR infrastructure itself. And I have to admit, I don't know the number by heart, but I don't want to lead you into a wrong direction either.
Thanks very much, Kewan. Okay, so I'm told we can't take questions online, but and given the limited time, we are going to do one more round from the room and then conclude. So we have a question over there, please. Thank you very much.
Thank you very much. I have a question about the equity, underlying equity in the scenarios that you presented. So you have, for example, shown that there is some reduction in C1 scenarios between Annex 1 and non-Annex 1 regions. But there are, if you look at the regional breakdown, it shows that Sub-Saharan Africa, for example, stays at around $9,000 or $10,000 till 2050. South Asia stays at around $15,000 till 2050. Are these levels of GDP or levels of consumption enough for these regions, which are large regions, 30% of the global population, to overcome poverty? And so therefore, equity is not just about whether the gap reduces. The question is also that the gap still remains, and remains quite substantially, even how is it that when you say that things, I mean, things look better, and in the summary assessments that you provide, where you give intermediate or median values, what happens to the one scenario which has high equity if it doesn't fall in the 5 to 95 percentile range or the interquartile range? I mean, how is that accounted for?
Thank you very much. Okay, we'll take another question. If there is any, I can't see any hand. Okay, so we will conclude with this question. I guess, Kewan, since you presented the equity, would you mind answering?
Yeah, this is. I mean, first of all, I think one has to recognize that in the scenarios, the growth rates in the developing world, in terms of economic development, are even on average much higher than in the north, and that those growth rates are not in any significant way negatively impacted by the climate mitigation activities. So what I presented was the underlying assumptions about income convergence in those scenarios. And there is a certain range of income convergence across different scenarios that achieve 1.5 degrees, staying below 1.5 degrees in different ways. We purposefully selected the IMP SP, the shifting development pathway, because of its very favorable equity assumptions, because we thought we want to have at least one scenario in that set of 5 mitigation pathways that features a very rapid income gap closure. I think it's a very challenging, it's a daunting task to close, to improve equity as much as it's in this shifting development pathway. But we show also that there might be different economic developments in the world which are also consistent with 1.5 degrees. Yeah? So that's the way that the scenarios need to be interpreted. If you're mainly interested in a very highly equitable world, this is the IMP SP is the results to look into. But there are many other scenarios where the equity is also improving, but not that much. But let me add perhaps one really important element. The important element is that if we translate these scenarios into in terms of justice, fairness, equity, all the results show us that the financial transfers will be needed in order to make the realization of these scenarios also really equitable at the end, right? So equity is not only about the economic assumptions underpinning the modeling, because they need to be realistic. If countries are at a lower development stage and need to take on high burden in terms of mitigation, the question is always, where does the finance come from? And this is what I hope there will be some outcome at COP27, because that's actually needed in order to unlock that the investments are really happening then at the end.
Thank you very much, Kewan. I think we will have to conclude now. Oh, we have one question online. Excellent. Right, okay. So we have a question to you, Kewan. The temperatures provided for the different scenarios categories are for 2100. Which of the categories indicate these temperatures are stabilized temperature by 2100, and which categories continue warming past 2100? So is the peak warming 2100 versus this is the measurement of 2100 and the peak warming comes beyond the 21st century, essentially? I'm not sure if you have this off the top of your head, but perhaps Mark.
Actually, Malte showed even the temperature graph. I cannot remember which ones it were. Definitely in category 7 and 8, warming continues. And then in the lower categories, in some scenarios, warming peaks, and in some scenarios, warming actually continues. I'm looking at Detlef and Malte, who probably cannot hear me, but might have the figures in front of them. But there is a footnote to the table in the summary for policymaker, which actually makes exactly this point in this book here, which exactly points towards which categories have scenarios where warming continues, and in which categories scenarios have a peak before the year 2100. So I think that's covered here.
Malte, we can hear you. Please go ahead.
Already in category 5.
Malte, go ahead. We can hear you. There is a bit of delay, but go ahead, please. Right. Okay. I think it's a good. I'm afraid it's a good moment to finish the event now. Thanks so much for bearing with us. Apologies for the technical difficulties. It's the first event here in the pavilion, so we had to bear through these conditions. As you will know, Working Group 3 is hosting a long list of series of events here about demand, on finance, feasibility. Perfect. Thanks, Malte. So C5 to C7, they stabilize. Okay. Thanks to the speakers. Thanks to you for bearing with us. Thanks to my colleagues in the TSU here, David, Roger, and thanks very much to Siggy for organizing the long list of events. It's been a lot of work, and thanks to the technical support. Apologies again. We will upload the slides online, and we promise the next event will be up to much better organized than this one. We have the printed SPM outside. Please grab a copy for yourself, and hopefully see you in the next event. Thank you very much.
Wait a second. What do you want? Ah? What do you want? Do you want me to speak with the Zoom?
Tal cual. Ya, tal cual. Está la Natalie, podemos notar si...
Sonia.
First off, what is the order?
Sonia, Cristo viene presencial o se conecta.
So then you want...
Cristo tiene presentación.
Aquí no me han dado nada, ¿vale? De repente también para en el mismo chat podríamos poner el tiempo o cómo lo queremos hacer con los tiempos. School virus transmission. Talking. ¿Agarro el micrófono? Ya.
Pero no sé si estamos listos para partir.
Sí, tú me decís no. puro gastando pura masa. El orden real. Sí, y después al final la sopa. Tal cual lo que hicieron con él. Para no cambiar el... Sonia. It was off. Here. We're good. Sonia, ¿puedes hablar?
Hola.
Okay. Estamos listos. Sonia, ¿escuchas? Sí, se escucha. ¿Escucha ahora? ¿Escucha ahora? Ok. Hello. We'll begin in a minute. We're just gonna get the streaming ready and we'll start.